everyone, I'm Eddie. Welcome to my channel. I've created a set of SAT math questions that you can access via the link in my description. The quickest path to an 800 is practice, so this problem set will surely help. Let's dive right in. It's time to lock in.
Number 1, Sarah is 3 times as old as her younger brother. So Sarah is equal to 3 times as old as her younger brother. In 4 years, the sum of their ages will be 40. So in 4 years, Sarah will have gained 4 years, and her brother will have gained 4 years, and these two added together will equal 40. Now, how old is Sarah right now? We know that Sarah is equal to 3 times her brother's age, so Sarah will equal 3b. So we can substitute just like this. We can also do some simplifying here, combining like terms. 3b plus b is 4b. 4 plus 4 is 8. Subtract 8 on both sides. 40 minus 8 will give us 32. So we know her brother currently is 8 years old. Now, Sarah is 3 times as old as her younger brother right now. So we get S is equal to 3 times 8, which is 24. Kobe. Sarah is 24 years old. Number 2, an equilateral triangle has a perimeter of 1,500 feet. So equilateral triangle has a perimeter of 1,500 feet. Now, what is an equilateral triangle? It's a triangle with congruent sides and congruent angles. In this case, we only care about the congruent sides. If the height of the triangle is equal to, if this height right here is equal to x radical 3, what is the value of x? Now, the equilateral triangle, it also just so happens that the angles are also important here. We have 60 degrees, and this 60 degrees is bisected. So we have 30, 60, 90 triangle. We can redraw this down here. We'll have a 60, 30, 60, 90 triangle. Here is 500. So we know that half of the hypotenuse of a 30, 60, 90 triangle will be the shortest leg of that triangle. So we have 250 over here. We can multiply the shortest leg by radical 3 to get to the height of this equilateral triangle. We were asked for x. X will be 250. A cool trick that you can use the next time you have a question like this is if you're given the perimeter of an equilateral triangle, just divide that number by 6 to get to that value of x. And that works because if you think about it, if we split each of these equilateral triangle sides, there are 1, 2, 3, 4, 5, 6 of those half sides, and we multiply that by radical 3 to get to the longer side of the 30, 60, 90 triangle. Number 3, in the system of equations above, if a is equal to b and both a and b are positive, what is the value of y? Well, if a is equal to b, we know right off the bat that we can substitute a in for that b. So we can use elimination here, subtract the entire second equation from that first equation. The a x's will eliminate, will go poof in the night, and negative 9y minus 3y will become negative 12y. 12 minus a negative 48 gives us 60, and we can see the light at the end of the tunnel. Boom, there it is. Y will be equal to negative 5. Problem number 4. A box contains 5 red marbles and 7 blue marbles. So total 12 marbles in total. 2 marbles are selected at random without replacement. That's really important. Given that the first marble selected was red, so now we have 11 marbles, and we have 4 red marbles and still 7 blue marbles in the box. What is the probability that the second marble is also red? So we have 4 red marbles left out of a total of 11. Boom. 4 of 11 will be correct here. Question number 5. What is the value of 7 times quantity a minus 4? Now, notice how both equations up here in the system of equations have an a minus 4 and a b plus 9. We're also given a minus 4 as a part of the value that we're solving for. So why not just call a minus 4 x and b plus 9 a y? So now we have, what are we looking for? 7x. And our new system of equations will be x plus 5y is equal to 124, and x minus 10y will equal 52. We can use elimination or substitution, whatever we'd like. However, in this case, we do want to solve for the x, so we don't really want to eliminate the x's here, right? Strategize. We want to get rid of the y's, and it becomes very convenient once we multiply the top equation by a 2 we get 2x plus 10y is equal to 248. And I can rewrite that down here, actually, just so we're not blocking any of our work. We get 2x plus 10y is equal to 248. Using these, we can add straight down. X plus 2x is 3x. The negative 10y and positive 10y go poof in the night. And we have 52 plus 248 is 300. X is equal to 100. But be careful, that's not our final answer. We are looking for 7x. 7 times 100 is 700. Number 6. If p is a prime number, how many factors does p cubed have? Now, a strategy that I like to use with my students or suggest to my students is, just plug in a number. What's a prime number that you know? I know 2 is a prime number. So let's say p is equal to 2. Then 2 cubed is equal to 8. What are the factors of 8? 1, 2, 4, and 8. That's how we know 4 will be the answer. Another way we could have gone about this is we could have said 1, p squared, and p cubed. We could have done a factor tree. We could have done a whole bunch of things. We could have done 1 times p cubed and p times p squared. There are our 4 factors. Number 7. Let a and b be numbers such that a cubed is equal to b squared. Which of the following is equivalent to a square root b? Notice how all the answer choices here are in terms of a. So we want to change this radical b to be in terms of a. So you have a times the square root of b, which is b to the 1/2 power. Let's solve for b from this equation then. We have a cubed is equal to b squared. I can take the square root of both sides, or in other words, take each side to the 1/2 power. And whenever we have a power to another power, we can multiply those two powers, which is why these will go poof in the night, become a 1. They will cancel. And I have a to the 3/2 here. I'm going to go ahead and substitute this for this. So this b is going to become a to the 3/2. So if a times a to the 3/2 to the 1/2, we can multiply a power to another power. We have a times a to the 3/4. A by itself is to the first power. That 1 can be changed into a 4/4. And since we have the same base exponents being multiplied, we can add the powers, and that gives us a to the 7/4. Let's continue our speed run here. Number 8, if x plus 1 squared is equal to 4 and x minus 1 squared is equal to 16, what is the value of x? The easiest way to go about this is to go step by step. Don't try to just dive into the problem ever. Always think about what's given and what we can do. So here, x plus 1 squared, let's solve. We can take the square root of both sides of an equation, but whenever we do, we must consider both the positive and negative version of that square root. The square root of 4 is 2. We consider both the positive and negative version. We can split this into 2 equations. And we get x is equal to 1 and x is equal to negative 2. We're going to check both of these to see if it works. Because right now, 1 and negative 2 are both answer choices, but we're not quite sure where we will go with this. Oh, I realized I made a mistake here. All good. And I caught my mistake here because I knew I had something wrong here. Subtract the 1, 3. I also noticed negative 2 is not an answer choice. So 1 and negative 3 are my answer choices. Boom, B and D automatically not going to be answers. Plug either of these in. When I plug in 1, clearly that's going to give me a 0, so 1 is not going to work. X equals negative 3 is our only answer for this problem. Whew. Number 9. An integer is subtracted from its square. An integer, that's an unknown. So if x is subtracted from its square, what do you notice? This is a pattern that we need to recognize. Factoring is huge. Let's factor out an x. We have x times x minus 1. What do you notice about these two numbers? It is a product, and it is a product of 2 consecutive, not just even or odd integers, but just integers in general. Reminder that an integer is any number, any whole number, like 1, 2, 3, 4, but also negative. Negative 1, negative 2, negative 3, negative 4, including the number 0. Number 10. What is the radius of the circle represented? The radius of a circle can be found if we have it in this form. Squared is equal to r squared, something like this. Now, we don't need to know what h is. We don't need to know what k is. We only need to know what r squared is. So we're not going to worry about completely simplifying here, we only care about what r squared is. So let's go ahead, put this in terms where we are able to complete the square. I moved this negative 21 to the other side. Everything else I just kind of structured and organized so that the terms that are similar are together. Now from here, half of negative 12 is negative 6, and we're going to be adding a negative 6 squared. Therefore, I'll be adding a negative 6 squared here. Half of 16 is 8, and so I'll add that on this side as well. So now, r squared is equal to 21 plus 36 plus 64. 64 plus 36, very convenient. That gives us 100, plus that 21 gives me a 121. When I take the square root of both sides of an equation, I need to consider both the positive and negative version. However, when we're talking about the radius of a circle, only the positive matters because we're talking about distances here. So the radius is 11. It would have been cool if 121 was an answer choice here. That would have been a trap answer choice. Number 11, a square is inscribed in a circle. Usually we're given circles within a square, but this time we're given a circle and a square within. Now from here, if the area of the square is 64 square units, we know right off the bat, each side of the square is 8, giving us the diagonal, which is 8 radical 2. That's also going to be the diameter of this circle. They're asking for the area of the circle. Notice how right when I got to this problem, I just wrote down everything I knew about the problem. Also because I saw pi in our answer choices, I knew I was going to be working with the circle because I'm given everything we know about the square. So just get in the habit of doing that, right? It's not wasting any time. It's getting all the information you need and want and might want in this problem. And in this case, it worked out. The radius is 4 radical 2. The area of a circle is pi r squared. 4 radical 2 squared is 16 times 2, which is 32 pi. Answer choice B. Here's the very last one. This one is actually one of the easiest one, but it looks a little dense because we're given a whole bunch of fractions, exponents, and whatnot. But take a look at what we're trying to solve for. We're trying to solve for 1 over xy. We're given x to the 10th and x to the 9th. What do we need to do to x to the 9th to get to x to the 10th? What if we multiplied by x on the top? In order to do that, we must also multiply the bottom by x in order to maintain the equality or maintain the balance of this term. So now if x to the 10th over xy is equal to 5, 5, 5, 5. Well, we know what x to the 10th is. That is equal to 5. So if we have 5 over xy is equal to 5,555, I can divide both sides by 5 to get 1 over xy itself. I'll get 1,111. Boom.
If this helped you, make sure you subscribe. I'm going to be posting a lot more SAT math content, breaking down specific topics, common traps, how to move from a 600 to a 700, and from a 700 to an 800. Drop a like if you found this useful. It genuinely helps the channel. And comment what SAT math topics you're finding challenging below. I actually read them, and it helps me create new problems for future videos. Also, definitely check out my other SAT math videos. I've already covered a lot of specific question types and common misconceptions. If you're serious about that 800, go watch those next. See you in the next one.